right, so we're about to explore how AI is literally breaking out of our screens and into the real world. And I'm not just talking about another chatbot. We're talking about AI that can take control of a robot on a factory floor and manage an entire global supply chain. Let's dive in. Just look at this slide. This right here is the whole revolution in a nutshell. On the left, you've got this clunky, rigid code that needs a specialist to write it. And on the right, a simple human instruction. You see, we're shifting from being programmers who have to meticulously define every single tiny movement to becoming instructors who just state the goal. And that changes everything. So let's start where the action is, the factory floor. How do we actually get from that rigid line of code to a robot that just gets it when we give it a command? It's not about following a pre-drawn path anymore. We're actually teaching these machines to understand what we want to happen, our intent. And this is the magic ingredient, large language models, or LLMs. You gotta think of them as the brain that connects our world of ideas to the robot's world of physical action. They are the ultimate translators, taking our simple, high-level goals and breaking them down into the series of precise movements the robot needs to actually perform. But for an LLM to be useful in the real world, it needs senses. And that's where this term multimodal integration comes in. It's really just a fancy way of saying the robot can process information from all its different senses at once, what it sees, what it hears, and its own motor controls, and infuse them all together into a single cohesive thought, just like we do. Okay, here's a perfect practical example. The robot's vision system sees a person walk into its path. At the same time, its language processor hears the command, stop, and its motor control system slams on the brakes. These aren't three separate things happening. It's one seamless, intelligent reaction to a complex situation. So, the robot can see and hear, that's great, but what happens when the environment changes unexpectedly? That's where contextual reasoning is so crucial. This is the robot's ability to adapt on the fly. It can see a wet floor sign, understand what that implies, and decide to take a different route, all without a human needing to write a single new line of code. This flexibility is a total game changer. And this really is the core idea, the big takeaway. We provide the what, and the agent figures out the how. Now that's amazing for one robot, but what happens when we apply this exact same logic to something much, much bigger, like an entire global supply chain? Let's zoom out. So now we're pulling way back, looking at the entire global logistics network. And the principles are actually the same. It's all about understanding goals and context. But here, the body that the AI is controlling isn't a single robot arm. It's the whole worldwide flow of goods and materials. Now, for an AI to manage something this complex, it has to be able to see everything. It can't just look at one part of the puzzle. It needs to see the entire board, all at once. And that means it has to tap into all the core information systems of a business to get a complete, real-time picture of what's happening. The first stop is the company's central nervous system, its Enterprise Resource Planning System, or ERP. This is where the agent finds the ground truth. It learns the fundamentals. What inventory do we have? What are our production capabilities? What are our costs? It's the source of all internal data. Next, it gets its eyes and ears out in the real world through the Internet of Things, or IoT. This huge network of sensors is feeding it live, real-time data on, everything. From the exact GPS location of a shipping container to the temperature inside a refrigerated truck. And finally, to actually make things happen, to move things around, the agent plugs into the Transportation Management System, or TMS. You can think of this as the control panel for the physical world of logistics. It handles all the routes, carriers, and the nitty-gritty of shipping. Okay, but wait. How does the agent talk to all of these different complicated systems at the same time? I mean, an ERP from SAP and a TMS from some other company don't naturally speak the same language. That's where this really critical piece of infrastructure called the integration layer comes into play. And the heart of that layer is the API management system. Honestly, the best way to think about it is as a universal translator for software. It takes all the messy, complex languages from all these different systems and creates a single common language that the AI agent can speak and understand. This is what lets it pull data from a weather satellite and send it instruction to a trucking company all in the same breath. Okay, so now we have an agent making potentially millions of autonomous decisions, rerouting shipments, ordering new parts. This brings up a massive, crucial question. How in the world can we trust its actions, especially when it might be sourcing new materials from a supplier we've never even heard of before? And look, this isn't just some philosophical debate. For things like legal compliance, quality control, and just basic financial accountability, we absolutely have to be able to trust the system. If we can't prove, without a doubt, where a part came from, we have a really serious problem on our hands. The solution, it turns out, is blockchain. It provides a secure and, most importantly, an unalterable digital ledger for the entire supply chain. Every single step of a product's journey gets recorded permanently. This creates something called provenance, which is basically an unbreakable, verifiable history of where something came from. It's the only way you can truly trust an autonomous decision at this scale. What's so cool about this is how it makes a really abstract concept feel tangible. Every one of these steps, from the raw materials to the final delivery, is recorded as a permanent, cryptographically secured block in a chain of events. And the key is, it's not a record that can be edited or deleted later. It is the verifiable truth of that product's entire history. Okay, so let's bring all of this together. We've seen how an agent can physically act in a factory, and we've seen how it can think systemically across a massive global supply chain. So what's the ultimate payoff? What's the big advantage of all this complexity? This slide right here, this is the bottom line. It's the massive difference between being reactive and being proactive. Your traditional systems are reactive. They send you an alert after the problem has already happened. But an agentic system? It's proactive. It's analyzing news feeds, weather patterns, all kinds of data to predict a potential disruption, and then it presents you with a solution before it ever becomes a crisis. So yeah, we're moving from just reacting to problems to actively getting ahead of them. But it's even deeper than that. The real key here is that the agent is always learning. It's not just solving today's problems, it's getting smarter and better at predicting tomorrow's problems by analyzing the results of its own decisions. This continuous cycle of learning and optimization, that's the real long-term advantage. And that really brings us to the final and maybe the most important question. If our machines can now anticipate and solve these incredibly complex physical problems for us, what does that leave for us to do? This isn't about replacing people. It's about elevating them. It frees us all from constant crisis management so we can focus on strategy, on innovation, and on the truly human challenges that lie ahead. The question isn't just what's next for technology, but really, what's next for us?